Hi everyone, this is Harkirat Pekar and with me today you are going to do chapter 6th of class 9th NCERT lines and angles. So let's start with the chapter. So before we start with the topic, let us try to understand why the study of lines and angles is important. See, I have shown various figures in which you can see this is window pane. You can see both angles and lines in all these figures. Here one line, this is also line, angle, 4 angles you can see. Here in road also you can see this is angle, this one. Straight roads means again we need to have the knowledge of lines. This is laptop, it is making an angle. This is clock. See the hands of the clock, they are again making angle. And in chair also if you see this is line, this is one angle. See, these are the figures which I have chosen from our daily life. Now if you have to prepare some model also, so model by using bamboo sticks, you can see here also only if you have the knowledge of lines and angles you will be able to make this model. In science also we have to study ray diagrams, so in that also we should have knowledge of lines and angles. You can see these are lines, these are angles. So that's why the knowledge of lines and angle it's very important. In every field it's required. Now in this chapter we have to deal with certain terms. I'm sure all these terms you have done in earlier classes also, because basic terms I am going to explain now. So what is line? So line, it is defined as a straight one-dimensional figure that has no thickness and extends endlessly in both the directions. So this is line. It can extend in both the directions and it has not any thickness, you can see. So line is represented in this way. 2 arrows are there. And these arrows, they are representing that line has no endpoints. Next one is line segment. See, line segment, it's a part of a line that is bounded by 2 distinct endpoints and contains every point on the line between its endpoints. So basically line segment, it's a part of a line. See, this is line. This complete, it's a line. You can see these arrows, they are representing that this has no endpoints, but the part of the line, see A and B, see AB, it has endpoints. So part of the line is a line segment and it is represented in this way. This one and this are the 2 endpoints of this line segment. Next one is ray. A ray can be defined as a part of a line that has fixed starting point but no endpoint, and it can extend infinitely in one direction. See, line segment, it has 2 endpoints, but ray, again it is also a part of line, but it can extend only in one direction, since it has starting point but it has no endpoint. So a ray, it is represented in this way. It has one endpoint and other side it has no endpoint. Now let's study about collinear and non-collinear points. So 3 or more points, they are said to be collinear if they lie on a single straight line. See, this is one line. See, whenever these arrow marks are there on both the sides, it is showing us that this is a line. And you can see on this line 4 points are there, A, B, C and D, due to which these points are known as collinear points since they are lying on one line. Non-collinear points, they are a set of points that do not lie on the same line. We can see now these points D, E and F. See, these points are not lying on a line, so they are known as non-collinear points. On the other hand side, if you see this thing, points A, P and C, they are lying on a line. So these points are known as collinear points and these points D, E, F are known as non-collinear points. Now let's start with the angle. So an angle is the figure formed by 2 rays and these rays are called the sides of the angle, sharing a common endpoint which is known as vertex of the angle. You can see OA is one angle and OA is one ray and OB is another ray, and they are sharing common endpoint O. And this O, its point O, it is also known as vertex of the angle. So this is how angle is representing. This ray and this second ray, they are sharing common point which is vertex. Now let's study about the types of angles. Acute angle. See, basically the types which we are going to study now, it's based on the measurement. See, on the degree, on the value of the degree. First one is acute angle. See, acute angle, it's an angle whose measure is between 0 and 90 degree. See, if any angle, it lies between 0 and 90, that angle, it is known as acute angle, and this is how it will look. Angle ABC, you can see, and this angle is of 30 degree, due to which this is acute angle. It is always, this angle always lies between 0 and 90. So this is how you can represent, because 90 degree is a straight angle, so it will always be like this. So any example you can take, this 30 degree, 40 degree, 50 degree, even 89 degree is also acute angle. Next one is obtuse angle. An angle that has a measurement greater than 90 degree but less than 180 degree. So any angle which lies between 90 and 180, it is known as obtuse angle. Say 150 degree, 118 degree. So basically an angle greater than 90 and less than 180. So which includes 91 degree also and 179 also. So all the angles between these two, they are known as obtuse angles. Next one is right angle. Right angle, it's an angle exactly 90 degrees. This is how it is represented. Straight vertical lines, and this is a symbol, this square symbol, this is used to represent 90 degree angle, and 90 degree angle is also known as perpendicular. So always it is represented like this. Next one is straight angle, an angle that has exactly 180 degrees. So exactly 180 degree, and it is straight line. So whenever you see any straight line, see this is one straight line and this is 180 degree angle. This is also one straight line. So this is 180 degree angle. This is straight line. This angle is 180 degree. So angle on a straight line is straight angle. Next one is reflex angle. So an angle which is more than 180 degree but less than 360 degree. So in other words, we can say more than a straight angle but less than a full rotation. So this is how it is represented. See, always like this, an angle which is greater than 180 and less than 360, it is a reflex angle. So it is represented in this way. The next one is complete angle, or this is also full rotation angle. So this angle which is equal to 360 degree, it is complete angle. So this is how we represent 360 degrees. See, one single line, you feel like this is one single line and you start from here and complete one full circle, and this is 360 degrees. So circle, this represent 360 degree angles, and this is known as complete angle or full rotation angle. See what happens here. See, let us take example of clock. When both the arms or both the hands of the clock, they coincide with each other, it forms an angle of 360 degrees. Same way, see, two rays are there. When two rays, they are overlapping each other, then complete angle is formed. So let's recap now all the angles. See, this is acute angle which is less than 90 degree, or we can say 0 to 90 degrees acute angle. Then right angle which is exactly 90 degree. Obtuse angle which is greater than 90 but less than 180 degree. Then we have straight angle. Straight angle, it has exact measurement of 180 degrees. Then reflex angle. So reflex angle, it's greater than 180 degree but less than 360 degree. So this is how it is represented. See, all these angles, I'm sure you might have knowledge of these angles as you have done in earlier classes also, but here in this chapter also we should have this knowledge, because we have to find certain angles. So they can mention find this angle or that angle or find reflex angle. So that's why you should know all these terms. Now, types of lines. There are two types of lines. First one is intersecting line and the other one is parallel lines. So intersecting lines. So the word itself, it is suggesting when two or more lines they cross each other in a plane, they are called intersecting. So intersecting lines, they share a common point which exists on all the intersecting lines. You can see just they are crossing each other, two lines, and they share one common point. So these two lines, they are intersecting each other at this point. So this is their common point. Here I have taken so many lines. See, this line, first line, second line, third line, four lines are intersecting at this point. So this is their common point. Then here this so many lines, they are intersecting. So basically you have to understand, when the lines they are crossing each other and sharing one common point, those lines are known as intersecting lines. The other type of the line is non-intersecting line, and non-intersecting lines are also known as parallel lines. So two or more lines that do not intersect each other, they are known as non-intersecting lines, and it is to be noted that non-intersecting lines can never meet. So they can never meet, they cannot intersect, and they are also known as parallel lines. So you have to remember these things. See, non-intersecting lines looks like this and they will not meet each other at any point. So straight they will go. Now this was all about lines. So two types we have discussed. Now angles also we have discussed, but those angles, they were as per their degrees we have learned. Now we have few more important types of angles. The first one is complementary angles. So when two angles add to 90, we say they complement each other. Basically, if you add two angles and their sum is equal to 90 degree, so they are known as complementary angles. Now I have taken one example. See, I have two angles. First angle is 60 degree, the second one is 30 degree. So if I am adding 60 and 30, I am getting 90 degree, which means 60 and 30 are complementary angles. Basically, on adding two angles, if you are getting 90 degree, those angles are complementary angle. Here in second example also you can say 40 plus 50, it is equal to 90 degree. So which means angle, this one 40 degree and 50 degree, both are complementary angles. Next one is supplementary angles. So on adding two angles, if we get their sum equal to 180 degree, so those angles are known as supplementary angles. See, now I have two angles, angle A and B. If I get 180 degree on adding angle A and B, so which means angle A and B are supplementary angles. So let's take one example also. 130 plus 50 is equal to 180 degree. So which means 130 and 50 are supplementary angles. Then adjacent angles. Two angles are adjacent when they have common side and common vertex and they don't overlap. See, they have one common vertex. First figure, if you see, this is one angle 35 degree and the other angle is 55 degree. They are sharing common vertex also and they have common arm also, or common ray also we can say. So these type of angles, they form a pair of adjacent angles. Here again if we take this example, so 80 degree and 45 degree are adjacent angles. Why? Because they are sharing common vertex. See, vertex is common. Moreover, they are sharing common ray also. This with green color it is marked. So the other one, angle 85 degree and angle 20, they are sharing common vertex and common ray. So which means 85 and 20, they are a pair of adjacent angles. Same way, these two angles 130 degree and 50 degree, they are sharing common vertex and common ray, due to which they are also known as adjacent angles. So this one thing you have to remember. If you are not able to recognize also, you just have to see two things, whether the angles are sharing common ray and common vertex. So if they are sharing, then those angles, they will be adjacent angles. Now this was all about angles. Now we have some axioms and theorems which we have to use while solving the questions of the exercise. So axiom is some, we don't have to do any proofs of axiom. We just have to assume that these are the true statements and we can apply these results in while solving our questions. So I'll explain you whenever I use this axiom while solving the question. So axiom 6.1, it is saying, see, if a ray on a line stands, so then the sum of the two adjacent angles so formed is 180 degree. See, this is one line. So what it is saying, if on a line one ray stands, see, AOC is one line and OB is the ray which is standing on this line. So if this is the situation, then angle 1 plus angle 2, it is equal to 180 degree. Once again I will explain. I have one line AOB. If any ray stands on this line, so OB is a ray which is standing on this line, then angle 1 plus angle 2 will be equal to 180 degree. So this is as per the axiom 6.1. You can see also I have line AOC and OB is the ray. So I have taken the value of angle 1 as 40 and angle 2 is 140 degree. Now you can see on adding we get 180 degree. So this is how we can use this axiom while solving the questions. So here also you can see this is one line AC. So OD is the ray. This way if we see, so if on a line any ray stands, then the sum of these angles, so in this case angle 1 plus angle 4, it is equal to 180 degree. And if we see this OB as a ray, if we see, then angle 2 plus angle 3, it is equal to 180 degree. This is as per axiom 6.1. So axiom 6.2, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. So this is completely converse of axiom 6.1. So in axiom 6.1 it was mentioned that this is a line and this ray stands on this line. But here it is mentioned now the sum of these two angles, this is 80, and if the sum of these two adjacent angles is equal to 180 degree, then this is a line. See, if this angle plus this angle is equal to 180 degree, and then the see it's mentioned non-common arms of the angle. See, these are the non-common arms. If you see this angle AOB, then OB and OC are the non-common arms of these two angles. So these non-common arms of the angles, they will form a line if the sum of these two angles is equal to 180 degree. So these two axioms we have to use in questions while solving the questions of the exercise, and the next we have one theorem. So let's do the theorem now. So let's do the proof of theorem 6.1. So theorems we always have to do the proofs, because in exams also sometimes proofs can be asked. So that's why, so these proved results we can use while solving the questions of the exercise. So let's start. Theorem 6.1, it says if two lines intersect each other, then vertically opposite angles are equal. So while solving any theorem or while doing the proof of any theorem, first of all just write what is given to you. So given the two lines, they are intersecting each other. So we can name it, or simply you can mention two lines intersect each other. This is given to us. Two intersecting lines also you can mention. Now first thing is given, you have to write. Second thing is to prove. So what you have to prove? So it's, if lines intersect each other, then, so what is written after then, that thing you have to prove. Vertically opposite angles are equal. So this thing you have to prove. Vertically opposite angles are equal. Now let's start with the proof. See, sometimes because figure is not there, so we have to draw figure from our side. So two lines we can draw. See, I have explained you also. Lines we have to write, represent in this way. Two arrows should be there. So I have drawn two arrows on both the sides. So these are two lines. Let's name these two lines as AB and CD. And point of intersection, let's name it as O. So these are the two lines. So you can mention this point also, construction, because we are doing construction. So you can mention construction of AB. AB intersects CD. See, this way you have to write line. On the name, just above the name, you have to represent this symbol. So it is line. AB and CD intersects at point O. So we can name these angles. This is angle 1, this is angle 2, this is angle 3, and let's name it as angle 4. Because naming the angles, it will make easier, it will make the things easier for us to do the proof. So how you will see now. Now let's start with the proof. See, these are the things which you have to write. While solving questions of geometry also, just try to follow the same thing. First given thing, then to proof, then construction if any construction is there. But if the figure is already given to you, don't write anything and then proof. So what you have to prove? So here I will write vertically opposite angles. So vertically opposite angles are, see, the opposite angles. Like angle 1, it is vertically opposite of angle 4. Here also I will explain you, if I have two lines, intersecting lines, so this angle is vertically opposite to this angle. So if this is angle 1 and this is angle 2, so angle 1 is equal to angle 2 since they are forming a pair of vertically opposite angles. Same way, this angle is vertically opposite to this angle. So these two angles are equal. These are the vertically opposite angles. So what you have to prove? That angle 1 is equal to angle 4. So one thing we can prove, only one is sufficient. Either you can prove 1 is equal to angle 4 or you can prove angle 2 is equal to angle 3 because 1 is sufficient. So let's start. So we have learnt two axioms. So axiom 6.1 we will use here. We'll start on line CD, or any line we can choose. CD will choose first on line CD. So this is line CD, and you can see on line CD, OA, it is the ray. So this is how you have to represent ray, because ray, it has one end point and one where it can go endlessly. So this is how you can represent A. You can see on line CD, OA is the ray, and in axiom 6.1 we have learned if ray stands on a line, then sum of the adjacent angles is equal to 180 degrees. See, angle 1 and angle 2, these are adjacent angles. These have common vertex and common arm. So we can use on line CD, OA is a ray, therefore angle 1 plus angle 2. So if you want full names, we can write angle 1 is angle AOD. So full names we can write angle AOD plus angle AOC. It is equal to 180 degree. So this is as per axiom 6.1. I have already explained you this axiom. So if any ray stands on a line that the sum of the adjacent angles is equal to 180 degree. So we can mark this as point 1. If you want, in place of these angles, you can also write angle 1 plus angle 2, because we have already named the angles. So this is how we have to name the angle AOC and angle AOD. See, the vertex always you have to write in the middle. So while naming the angle, so AOD you can also write as DOA, and AOC you can also write as COA. So arms you can write either way, both ways are same. Now, so this is, we have taken line CD. Now let's take line AB. So on line AB, we'll take this OC as the ray. Why we are taking this? Because in both this is the common angle. So let's take in this way. Don't take this way, CD and OB as the ray. Assume this way. See, if I have this line, so here I am just drawing, so I am taking this ray OC this way. Just I can erase this so that it won't create any confusion. Now I am taking line AB, and the ray which is standing on this line is ray OC. OC is a ray. So therefore these two angles, angle AOC plus angle BOC, it is equal to 180 degree. Why 180 degree? Axiom 6.1. See, so why I have taken this line this way? Because see, here also AOC is there and here also AOC is there, and I had to prove somehow vertically opposite angles are equal. So I'll explain you. Now you can see, let's mark it as point number 2. See, both point 1 and point 2, they are equal to 180 degrees. So directly what we'll write? So we will write angle AOD plus angle AOC, it is equal to angle AOC plus angle BOC. See, both of these terms, they are equal to 180 degrees. So that's why if they are equal to 180 degree, which means they are equal to each other also. So you can mention here from 1 and 2. So reason also you have to mention everything while doing a proof of a theorem. So you have to mention everything from first and second, because any two terms which are equal to a common term, they are equal to each other also. Now AOC, it's present in both, so we can cancel. Same terms on equal sides of the equation, we can cancel directly, because if you change the side also, see. So I'll do here AOD plus angle AOC. Let's bring this AOC to this side. So this is plus AOC. So if I shift it to this side, it will be changed to minus AOC. It's equal to angle BOC. Let's keep BOC to that side only. So AOC minus AOC, we can directly cancel because it will be 0. So whenever I just explained you, so whenever any two same terms with same signs also on both the sides of the equation are there, so you can directly cancel. Now therefore remaining terms we can write angle AOD is equal to angle BOC. So which is your angle AOD? AOD, this one angle 1. So here I can write angle 1. BOC, angle 1 is equals to angle 4. See, this is how I explained you. Angle 1, it is vertically opposite angle of angle 4. So that's what we have already proved. Now you don't have to prove angle 2 is equals to angle 3. Similarly you can mention. Similarly, full proof, because it's understood if you take this line and now this way if you take OD as your ray, it will be proved that angle 2 is equals to angle 3. So instead of doing whole step directly, you can write similarly angle 2 is equals to angle 3. Hence, vertically opposite angles are equal. And this result of vertically opposite, like this angle is vertically opposite to this, both of these angles are equal and this angle. So this result we can use in questions directly. We can use this theorem also, it can come. So that's why we have done the proof of this theorem. So now the concepts which are required while solving questions of exercise 6.1 are all completed. So I'll continue my next video with exercise 6.1. So if you like the video, do share, do subscribe. Thank you so much for watching the video. See you in my next one.